So our topic in this video is polynomial division. What this is if we're given a function, it's an expression of multiple terms of x, say x squared plus x plus 5, and if we want to know, well, what is f of x divided by x plus 2? So how many times can we get x plus 2 into our original equation? That's what polynomial division is for. So the way we would find that out, or write that out, is in the same kind of form as regular long division, where we'd have like 1060 divided by 8 or something, and where we kind of break it up stepwise, almost as like we're dividing 1000 by 8 and then 100 by 8 and then 60 by 8, and we're kind of summing up all of those different values as we go along, making it easier to work out by hand. We have the same process for dividing polynomials. So I believe our original equation was f of x is equal to x squared plus x plus 5, and we want to know what is f of x divided by x plus 2. So we have our original equation, the thing that we want to divide, that's our dividend, that'll go inside here. So we have our x squared plus x plus 5, and then we have the thing that we're dividing by, which is our divisor. We're going to put that on the outside here, just like with regular long division. And just how we kind of break things apart by their largest segments and then sum those up by dividing the smaller segments as we go, the same process applies for polynomial division. So the first thing we want to do, kind of like having this be our 1000 from our number 1160, this x squared we'll kind of consider on its own a little bit. And what we'll do is, since that's our biggest exponent here of x, we're going to look at our term and we'll find our biggest exponent of x, which here is just x, or x to the 1. Same thing. And so we want this to match this, both in its coefficient, which it already does. These are both 1, it's just not written. And then we want the exponents to match, and that's where they don't currently match yet. So what would we have to do to our divisor to get it to equal to our first largest term here? We would have to multiply it by x in order to get this largest term to equal x squared. So we would write that down up here, the thing we're multiplying by, which is x. So we have x times our divisor here, x plus 2. We're going to distribute, and that equals x squared plus 2x. So this value we'll write right beneath our original term here. So that's x squared plus 2x. And I like to draw a line under here to make it easier to keep going visually. Our next step is we're going to subtract these two terms. And so we have our full polynomial minus this new term here. This new term, again, is just equal to these two things multiplied together, so that the coefficients and the exponents of our largest terms match. So performing this subtraction here, we'll have x squared minus x squared gives us 0. And then we have x minus 2x is equal to negative x. And then it's not written here, but there's sort of a plus 0. So you could write it if you wanted to, just to keep things organized, or you can leave it off. We'll bring that 5 straight down, or you could think of it as 5 minus 0, which is positive 5. So that comes down with us, and we're going to repeat the whole thing again over and over until we're all the way through, kind of like our division here, where we would divide 8 into like 1000 or 11 here, whatever, as many times as we could, and then kind of our 100. We put a new term, and then our 60, new term, all the way down till we get a remainder. So it's just kind of cycling through that first step here. So now we want to do the same thing. Our largest exponent is 1 here. It's 1 here, so they're all matched. We don't need to multiply by power of x again. We just want the coefficients to match. So our coefficient here is positive. Here it's negative. So that means we want to get this to be negative. And so we'd multiply it by negative 1. Going ahead and distributing that through would give us negative 1 times x plus 2, which is equal to negative x minus 2. So we're going to write that here. Negative x minus 2. Remember, we're subtracting this term from our original term here. And so we have what comes out to negative x plus 5 minus all of negative x minus 2. And that comes out to be negative x plus 5 plus x plus 2. Or you can look at it for a top-down way, which would be negative x minus negative x, which will be negative x plus x, which is 0. And then we'll have our 5 minus negative 2, which is the same as 5 plus 2, which gives us positive 7. And you can do the same thing here. These x's cancel out, and this 5 plus 2 gives us 7. So now we're left with 7, which is not a power of x really. I mean, it could be x to the 0. That looks like a 6. X to the 0, but we don't need to do that. Instead, what we see here is that we don't reasonably get 7 divided by x without doing some sort of a strange 1 over x stuff. And so at this point, we're done. We would still want to divide this by x plus 2. However, for the prior mentioned reason, this doesn't divide by x plus 2 neatly anymore. So we can just write this down as plus 7 divided by x plus 2 as our remainder. Another way that that's written is just as r7, remainder 7, up here instead. So our final solution is given by f of x divided by x plus 2 is equal to x minus 1 plus 7 over x plus 2. And we can check that our answer is correct by multiplying both sides by the divisor here and hopefully getting the same value here over here. So we can go ahead and do that. We'll multiply both sides by x plus 2. That'll give us f of x on the left because it's just divided and multiplied by the same term, and those will cancel out if it was here. And that'll equal to x plus 2 times everything on the right, which is x minus 1 plus 7 over x plus 2. And we'll go ahead and distribute that through, which will give us x times x plus 2, which is x squared plus 2x. And then we'll multiply it by negative 1, so that's minus x minus 2. And then we'll multiply this whole thing, our remainder, 7 over x plus 2 times x plus 2. And we should see that these will cancel out because they're equal, giving us just 7. Now we combine our like terms, and we're left with f of x is equal to x squared plus x plus 5, which should be equal to our original equation if we did things correctly, as it is done here in this first example. So now we'll go on and do some more examples with the same process. We'll probably try to move through a bit faster though. So let's move on to that. We'll have a second example that's a little longer with something just slightly different here. So we'll have f of x is equal to x cubed plus 2x squared plus 0x plus 5. And so the way you may normally see this written out, they may just omit that 0x, so it'd be x cubed plus 2x squared plus 5. I'm writing that in here because it'll help us out with keeping things organized in our division. So let's say we want this divided by x minus 2. So very similar to the last problem, x plus 2, but now we're doing x minus 2. So we'll go ahead and write that out in our division form. So our divisor, or our dividend, will go inside, and our divisor will go outside. Again, I'm writing that plus 0x just to keep things organized for us. So we're going about the same process here. We have our largest term, x cubed, and its coefficient is an unwritten 1. Same here, our largest exponent of x is 1, and its coefficient is also unwritten as 1. So we want this to match up with this. The 1's good to go. We want the exponent matched, so we're going to multiply this by what we would need to get it equal here, which is x squared. So we'll apply that here, x squared times our divisor is x squared times x minus 2, which gives us x cubed minus x squared. This term goes up here underneath our original term, x cubed minus x squared. we're going to subtract those two terms. So we'll be left with 0 here, just going top down. 2x squared minus negative x squared is the same as 2x squared plus x squared, which means we have 3x squared. And this is where things are a little bit different from our last problem. We'll go ahead and move everything down. So we have plus 0x plus 5. May have spoken a little bit too soon. We'll see. No, what's coming up here? So we want to do the same thing here, where we're multiplying by some sort of power of x and exponent to get this equal to our first largest term here. In this case, the coefficients are different, so it'll be positive 3 to get this to equal here. So positive 3, and then we'll also need to multiply it by x because this is x squared and this is x. So we'll have 3x up here. And then 3x times x minus 2 is just 3x squared minus 6x. And we'll write that down here again. So we have 3x squared minus 6x. Again, we're subtracting these two terms. That gives us 3x squared minus 3x squared is 0. 0x, I wrote that here for this step specifically, so that we could see this more easily. We have 0x minus negative 7x, which is the same as 0x plus 6x. And that just gives us positive 6x. And 5 comes down. Now we do still have our x's for the largest terms are still the same power, but they have different coefficients, so we'll want to multiply this by 6 to get these to equal. So that times 6 is 6x minus 12. So we have 6x minus 12. Again, we're subtracting these two terms. This will give us 0, and then 5 minus negative 12 is positive 17. So again, this last term doesn't divide easily by x minus 2, so that'll be our remainder. Again, one of the ways we can write it is just r17, or we can write it as plus 17 divided by, or divides our x minus 2. Our final answer, f of x over x minus 2 is equal to x squared plus 3x plus 6 plus 17 over x minus 2. And it looks like I might have done something a little weird. Should have, let's see, so it should be x squared, that is x cubed minus 2x squared. That's where I messed up. Okay. Yeah, okay. So whenever I multiplied our very first term, x squared by x minus 2, that should have been equal to x cubed minus 2x squared, and I just wrote x squared here. So it should actually be minus 2x squared, which changes up the rest of our problem, which I'll go ahead and try to fix really quickly. You may have seen that a while earlier before I did. I apologize. So I'll give it 0, 2x plus 4x squared, 0x plus 5, so it's x squared plus x, which gives us 4x squared minus 8x. We subtract those two, that gives us 0 again, plus 8x plus 5. Multiply it again by positive 8. So we'll have 8x minus 16. Subtracting those again, 0, 5 minus negative 16 is positive 21. So our remainder is 21. I believe that is our correct answer now. So f of x divided by x minus 2 should actually equal to x squared plus 4x plus 8 plus 21 divided by x minus 2. And that should be our final answer, which I believe is correct. Now we can move on to our third example. So our third example, I'm going to skip writing now f of x is equal to. We know that goes on the inside, and then what we want f of x divided by will go on the outside. So our third example, we will do one that is very, very long, sort of as a challenge problem. So we will have a term now that has 3 terms as our divisor. We'll do this plus 5x minus 1. Now on the inside we have x to the 5th plus 3x to the 4th minus 6x cubed plus 2x squared minus 7x plus 13. In this kind of example, I just want to do, in order to show that we can do very long terms as well, divided by divisors that also don't just have x as our greatest power. So we can also do terms that have x squared, x cubed, whatever, divided through these very large terms. So we'll go ahead and get started on this. Same process. We have our largest term, x to the 5th, x squared. We want these to match, so we'll multiply this by x to the 3rd, because we add those exponents when we multiply through. So x to the 3rd times this whole term gives us x to the 5th plus 5x to the 4th minus x cubed. And again, we're going to subtract this whole term, giving us 0 minus 2x to the 4th, 3x to the 4th minus 5x to the 4th, and then negative 6x to the 3rd minus negative x to the 3rd is going to be the same as negative 6x to the 3rd plus x to the 3rd, which will give us negative 5x to the 3rd. That's not very neat. 5x to the 3rd. Everything else comes down. So 2x squared, whoa, that should have an x, minus 7x plus 13. And we're going to rinse and repeat all the way through the problem. So now we want this to be equal, so we'll multiply by negative 2x squared. And now our first term should match up when multiplied, so it'll give us negative 2x to the 4th minus 10x to the 3rd plus 2x squared. And then we're going to subtract all those terms again, so that'll cancel out to 0. We'll have negative 5x, which minus minus, that'll give us plus, so that comes out to positive 5x cubed, 2x squared minus, and again that should be squared, minus 2x squared will give us 0, x squared minus 7x plus 13. Rinse and repeat. Now we need it to be multiplied by 5x to match with the largest terms. And then that multiplied through will give us 5x cubed plus 25x squared, not 2x, minus 5x. And we'll subtract that whole term from the top term, giving us 0 minus 25x squared. Negative 7x minus negative 5x gives us positive 2x. And then plus 13 is left alone. Once again, now our exponents match, but the coefficient is still different. We can keep dividing this. I don't want to draw that line yet. So we want to multiply these by negative 25 to get them equal. That'll give us negative 25x squared minus 125x plus 25. Finally, we're going to subtract these two terms. The whole thing, don't just apply it to this first term here. So that'll be 0 again. 2x minus negative 125x is 127x. So plus 127x. 13 minus 25 is going to give us negative 12. And then we can see here, I believe, 2x. I want to make sure that I did that correctly. That should be negative 2. That's right. So I made that positive. Oh my goodness. This comes from here. The negative 7x minus negative 5x is the same as negative 7x minus 5x, which means positive x. So negative 7x plus 5x should be negative 2x, not positive. So then these added together should be 123x. not 127. The negative 12 stays the same. And then we can see here, even though it's not just an integer, our largest exponent of x is smaller than our largest exponent of x in the divisor. So we don't divide any further without it becoming a mess. That's just our remainder here. So r, to signify remainder, 123x minus 12. And we can go ahead and write out our final answer as this whole thing is equal, well, we'll write it out all the way. So x to the 5th plus 3x to the 4th minus 6x cubed plus 2x squared minus 7x plus 13 all over x minus 2 is equal to x cubed minus 2x squared plus 5x minus 25 plus 123x minus 12 over x minus 2. And that's our final answer. Wow, I changed that up a lot. That was from our last example. This should be x squared plus 5x minus 1. Okay, and that's kind of our challenging big example at the end of this video. Hopefully this was helpful in just demonstrating some examples of polynomial division and kind of going through the steps of the process. That's all. Take care.